Today I'm going to be talking about proving triangles are congruent. And this is our second day of triangle congruency proofs. So I'm just going to show you some more examples of triangle congruency proofs. Once again, the four-step process of proving triangles congruent. You can always go back to this, and if you get stuck, you can see where you need to go back and get some help. So let's do some of these proofs. First thing, we write down the given. Mn is congruent to MP. And O is the midpoint of NP. And the reason for writing that down is that it's given. Next, we're going to look at the given and draw it on the picture. Mn is congruent to MP. That's our first given. So we're going to do a dash here and a dash here. This one is a freebie. It's kind of like a present because that congruency statement is already written down, so you don't have to write it down again. So we can now look at the second given. O is the midpoint of NP. Well, if O is the midpoint of NP, that gives us two congruent segments. So we can write down NO is congruent to OP. And the reason for that is definition of midpoint. We have two congruency statements already, so now we need a third one. And I go back to the picture, and we either can draw on vertical angles or a shared side. This one has a shared side, so we can do 3 marks there, and we can say that MO is congruent to MO. And the reason for that is our reflexive property of congruence. We now have 3 congruency statements, so we can label our picture with our S's and our A's, and this is going to be a side, side, side. So now we're ready to write our proof down. Triangle MNO is congruent to triangle MPO, and that's because of side, side, side. Let's look at another one. We always write our given down first. So AD is parallel to EC, and BD is congruent to BC, and that's given. Whenever you have parallel lines, like AD is parallel to EC, I like you to highlight them. So let's highlight those parallel lines, AD and BC. I'm sorry, AD and EC. And then we highlight the line that's connecting it. Okay? That gives us the guidelines to put the swoopies, those 2 swoopies. Okay, it gives us congruent angles. So we can say angle ADC is congruent to angle ECD. And the reason for that is alternate interior angles congruence theorem. Alternate interior angles congruence theorem, because parallel lines give us alternate interior angles. The next one is another freebie. BD is congruent to BC, so we can just draw that on our picture. BD is congruent to BC. And that's already written down. So we already have 2 congruency statements. So all we have left to do is look at the picture. I see vertical angles, so I can draw in my swoopies. So we can say that angle ABD is congruent to angle EBC, and that's because of the vertical angles congruence theorem. Now that we have 3 congruency statements, we can label with our S's and our A's on our picture. That's an angle, that's a side, that's an angle, so we can write our proof, which is triangle ABD is congruent to triangle EBC, and that is our angle side angle. All right, let's do another one. Let's write down our given. Q is the midpoint of MP, and Q is the midpoint of ON. And that's our given. Okay, let's look at our first given. Q is a midpoint of MP. That means that these two pieces are congruent to each other, so we can say that MQ is congruent to QP. And that's our definition of midpoint. Let's look at our second given. Q is a midpoint of ON. So now these two pieces are congruent to each other. So we can say that OQ is congruent to QN because the definition of midpoint. We only have two congruency statements, so we have to find a third one, and I can draw on my vertical angles, those swoopies. So we can say angle MQN is congruent to angle PQO. And this is the vertical angles congruence theorem. Since we have three congruency statements, we can label our picture, and this is side, angle, side. So we can write down our proof. Triangle MQN is congruent to triangle OQP because of side, angle, side. All right, I have one more to go. Write down our given. Isosceles triangle DAG with base AG. And also that DR bisects angle ADG. And that's our given. Let's look at our first statement. We have an isosceles triangle. If we have an isosceles triangle, we can say that these two sides are congruent to each other. So we can say that AD is congruent to GD. And that's our definition of isosceles triangle. Our next given is that DR is bisecting angle ADG. So DR is going to bisect that angle into two congruent pieces. I call that one the happy face because it kind of looks like a happy face when I draw it. So that bisector cuts that angle into two equal or congruent angles. So we can say angle ADR is congruent to angle GDR because of definition of angle bisector. We only have two congruency statements, so we need a third one. So we look to the picture to see if there's anything that we can draw in, and they share a side. So we can put those two marks there, and we can say that DR is congruent to DR. And that's our reflexive property of congruence. We have three congruency statements. So now we can label our picture, and this is going to be side, angle, side. So we're ready to prove triangle DAR is congruent to triangle DGR because of side, angle, side. And those are my examples of a few proofs.